Unit 4, Lesson 6, Solving Trig Equations, Part 1. So today's lesson is all about solving the angle when you're given the ratio. You're also given a domain. Today's domains will be all straightforward. It's just going to be any value of the angle that falls between 0 and 360. So there's nothing extra that we're going to have to do here today. Just keep in mind that sometimes that domain might be bigger, and then I'll show you in later lessons how to deal with that. Okay, so when you're trying to solve for theta, the first step is always find the related acute angle. And it's really important that when you're solving for the related acute angle, you always take the positive value of the trig ratio. Okay, so our trig ratio here is positive 5/4, so we're good, it's already positive. But if that was negative, then when you're finding the related acute angle, remember you take the positive version of that ratio. Okay, and if you don't remember why you do this, it's because the related acute angle, or any acute angle, is always going to be in quadrant 1. And we know from the cast rule that all ratios are positive in quadrant 1. So it makes sense that we have to take the positive version of the ratio in order to find that related acute angle. Okay, so let's go ahead and find the related acute angle for our relation above. So tan of beta is going to equal 5/4. Okay, and then because this is not a special triangle, we're going to use our calculator to solve for our related acute angle. And our related acute angle is equal to 51 degrees. Okay, we'll always round it to the nearest angle. So that's step 1, find your related acute angle. Step 2 is determine which quadrants the terminal arm of our principal angle could fall in based on our cast rule. So the way you're going to do that is you're going to look at the original question, okay? And because our ratio is positive in the original question, we have to ask ourselves, which quadrants is tan positive in? Okay, so according to our cast rule, tan is positive in quadrant 1 and 3. Okay, so that's really helpful because that just means that our principal angle, the terminal arm of our principal angle, is going to be in quadrants 1 and 3. So now we just need to draw a terminal arm in quadrant 1 and 3 with a related acute angle of 51 degrees. And then we can calculate our value of theta. Okay, so knowing that tan is positive in quadrant 1 and quadrant 3, that means we have to draw a terminal arm in quadrant 1 and quadrant 3 with a related acute angle of 51 degrees. So that's what I've done here. Okay, so here's your terminal arm in quadrant 1 with a related acute angle of 51 degrees. And here's your terminal arm in quadrant 3 with a related acute angle of 51 degrees. So now we use this to find our principal angle. So our principal angle is the angle that falls between 0 and 360, starts at the initial arm, which is the positive x-axis, ends at the terminal arm that we just drew. Okay, so principal angle here is going to be the same as the related acute angle. Principal angle here is going to be 180 plus the related acute angle. So that means theta 1 is equal to 51 degrees, and theta 2 is going to equal 180 degrees plus 51 degrees. Okay, so the angles that satisfy our original expression is theta could be either 51 degrees or 231 degrees. Okay, sometimes there is an extra step. Okay, sometimes you have to find more than 2 angles if the domain is greater than 0 to 360. But because this domain is 0 to 360, we don't have to do anything else. Okay, so always these 4 steps. Find the related acute angle using the positive version of the ratio. Figure out which quadrants your terminal arm is in. Draw that terminal arm with the appropriate related acute angle, and then solve for theta. Okay, let's try that 2 more times. Here, we need to solve for theta, and we have a domain of negative 360 all the way up to positive 360, so angles can fall within that domain. So let's follow our original 4 steps from above. So first, we're going to use the positive value of this trig ratio to find our related acute angle. Okay, so cos of beta is going to be, okay, the positive version of that, so 5/7. And now because this is not a special triangle, we're going to go ahead and use our calculator to solve for beta. And you're going to get 44 degrees. Okay, our next step is to figure out which quadrants our terminal arm falls in. So to do that, we're going to look at our original expression. So where is cos negative? Because our ratio was negative in the original expression. Okay, so according to the cast rule, cosine is negative in quadrants 2 and 3. So that means we're going to draw terminal arms in quadrant 2 and 3 with related acute angles of 44 degrees. Okay, so here is a terminal arm in quadrant 2 with a related acute angle of 44 degrees. And here's a terminal arm in quadrant 3 with a related acute angle of 44 degrees. Okay, so that means our first value of theta is going to be 180 minus that related acute angle. And our second value of theta is going to be 180 plus that related acute angle. Okay, so our first two values of theta to satisfy the expression above would be 136 degrees and 224 degrees. Okay, so those are the possible values of theta between 0 and 360. Our domain, however, extends further than 0. It goes back to negative 360. So whenever the domain is extended on the negative side, you want to think, okay, there are going to be more values of theta that satisfy this expression. Okay, and because it extends down to negative 360, all you're going to do to find those other values of theta is you're going to take theta 1 and theta 2 and subtract 360 from both those values. Then if your answer falls within the domain, you know that is also a possible value of theta. Okay, so for example, our third value of theta is going to be 136 degrees. I'm going to subtract 360. Right, because if we look at our terminal arm, if we do one full rotation in the negative direction, we're going to end up back in that appropriate quadrant. So that could be another possibility. Okay, and we get negative 224. That falls within the boundaries of the domain, so that's another value of theta. Let's get another value of theta by taking theta 2 and subtracting 360. Again, negative 136 falls within our domain, so that's another value of theta. And this is again, right, if we go one full rotation in the negative direction, we end back in quadrant 3, so that's good. Cosine is negative in quadrant 3, and it falls within our domain. Technically, you'd want to subtract 360 now from these guys to see if you could get a fifth and sixth version of theta. But I think you guys are going to be able to know in your head that if you subtract 360 from both those angles, you get a number less than negative 360. So you're out of the domain, so those would not be part of the answers. Okay, so there are 4 values of theta that satisfy this equation. Okay, let's try part B. Now, when you look at part B, you're going to think, well, this looks a little different than any question we've done before, right? Usually you just have sine theta, cos theta, or tan theta on one side of the equal sign and then a ratio on the other side. This one we've got some extra values in there. We've got a times 5 and a plus 3. So I don't want you to forget about this. Think of if sine theta, if we replace that with x, right, it would just be 5x plus 3 equals 1. You guys would know how to isolate for x in that case, right? You'd subtract 3 from both sides and then you'd divide by 5 and you'd get x by itself. We're gonna do the same thing here. We want to get sine theta by itself because then our expression is going to look like what we're used to. So let's subtract 3 from both sides and then divide by 5. Okay, now we have an expression that we're used to dealing with, right? We can clearly tell that our ratio is negative 2 over 5. So sometimes there's a little bit of extra work to be done before you can find the related acute angle. Okay, now let's find our related acute angle as normal. So I'm going to take the positive version of that ratio in order to find my value of beta. Because it's not a special triangle, I'm going to use my calculator, take the inverse of sine. We get 24 degrees as our related acute angle. Okay, now let's figure out which quadrants our terminal arm will fall into. So let's go back to our original ratio, so this guy here, and let's ask ourselves, which quadrants is sine negative in? Sine is negative in quadrant 3 and quadrant 4. So let's go ahead and draw a terminal arm in quadrant 3 and quadrant 4 with a related acute angle of 24 degrees. Okay, so I have a terminal arm in quadrant 3 with a related acute angle of 24 degrees, and I have a terminal arm in quadrant 4 with a related acute angle of 24 degrees. So my first value of theta is going to be 180 plus that related acute angle. My second value of theta is going to be 360 minus that related acute angle. Okay, so let's find our values of theta. Theta 1 is equal to 180 degrees plus 24 degrees. Okay. Theta 2 is going to be 360 degrees minus 24 degrees. Okay, now our domain has been extended past positive 360 and it's been extended past 0. So that means we need to add 360 to each of these first two angles until we get to 720 or beyond. And we need to subtract 360 from each of these angles until we get to negative 180 or beyond. So let's start by adding 360 to both these initial angles. So first we get 564 degrees, which is not quite at 720, so it does fit within our domain. So that's another possible value of theta. And then we get 696 degrees, which again falls within the boundaries in that domain. So it would count as another value of theta. Now you can see that if we kept adding 360 to theta 3 and theta 4, we would get numbers greater than 720. So we're finished. We've got all our angles that would fall within the positive side of our domain. Now let's go back to our original two angles and let's subtract 360 to get all the possible angles on the negative side of the domain. So now I'm going to take 204 and I'm going to subtract 360. And I get negative 156 degrees. Okay, and that falls within our domain. It's not past our domain of negative 180. So that counts. Okay, now I'm going to take 336 and subtract. Okay, we get negative 24 degrees, so that works as well. And again, if I took those values now and subtracted another 360, you would get beyond the domain. So that's as far as we can go. So for this question, we have 6 possible values of theta that fit within the domain. So those are all your answers, all possible values of theta. Okay, so again, to remind you of the steps, sometimes you have to simplify. Then it's always find the related acute angle, determine which quadrants those terminal arms are going to be in, then calculate theta based on those terminal arms, and then find all values of theta within the domain. Okay, I want you to pause the video here, try these two solutions, and then compare your solutions with mine. Okay, so these ones do require you to simplify first before you get the question started, and keep in mind that that part C has a different domain. Okay, part D's domain is just 0 to 360. Okay, so the first thing I did was I had to isolate for sine theta. Then I got to sine theta equals negative a half. Okay, then I went to solve for my related acute angle by taking the positive version of the ratio, so I took 1/2, not negative a half. And then I realized that I could solve for the related acute angle by using my special triangles. Using that special triangle, I realized that my related acute angle is 30 degrees. Then I looked at my original question and asked myself, where is sine negative? Okay, sine is negative in quadrant 3 and quadrant 4. So I drew terminal arms in quadrant 3 and quadrant 4, and those terminal arms had a related acute angle of 30 degrees. Then I calculated theta. The very first two values of theta that I calculated were not in the domain. Okay, so I just reject those answers. Then I tried to find other values of theta that fit within the negative side of the domain, because that is what was extended. So I subtracted 360 from my original two angles, and I got values of theta that fit inside my domain. Then I kept subtracting 360 degrees from my most recent values of theta, and I got 2 more possible angles of theta. Okay, if I subtracted 360 again, I know I would go outside of my domain. So, in conclusion, there are 4 values of theta. Okay, so this one might have confused you. When you started to isolate for cos theta, you would have got cos theta equals 0. Okay, and that might have confused you guys a bit. So whenever you see this happen, you're going to want to use your other trigonomic ratios, right? So we know that there's one version of the trigonomic ratios, which is SOHCAHTOA, but we also learned that you can write these trigonomic ratios in terms of x, y, and r. For example, we learned that cos of theta can also be written as x over r. Okay, so that means for cos of theta to be 0, the x value of the point on the terminal arm must be 0. So for cos of theta to equal 0, we just concluded that the x value of the point on the terminal arm must be 0. So we need to ask ourselves, where could you draw a point such that the x value is 0? Well, any point on the positive y-axis would have an x-coordinate of 0. So a point right here could have an x-coordinate of 0. So that means the terminal arm must be there as well. So the terminal arm in the first value of theta is right on that positive y-axis. Okay, so that means our first angle is the distance between our initial arm, which is always on that positive x-axis, and that terminal arm, right? And that's 90 degrees. So our first value of theta must be 90 degrees. Where else could a point lie such that the x-coordinate of that point is 0? Okay, it could also lie on the negative side of the y-axis. Any point on that y-axis is going to have a x-coordinate of 0. So I could stick a point there and it would have an x-coordinate of 0. Okay, and if the point's there, that means it's on the terminal arm. So the terminal arm must be that negative side of the y-axis. So now if I draw in my principal angle, so theta 2, I'm going to draw in the angle that goes between the initial arm, which is always that positive x-axis, and ends at the terminal arm. So theta 2 is going to equal 270 degrees. Okay, and that's as far as we can go, because if we were to add 360 to those numbers, we would get angle values outside of our domain. Okay, so this is just an example of when you would actually go ahead and use the other version of the trig ratios to solve for the principal angle.